Okay, so scientists theorized that masses create gravitational field in space. So how can we define gravity or gravitational force? We have gravitational force once we have interaction between a mass and gravitational field created by other mass. Okay, so every mass creates gravitational field around it. See, this is the earth, so we have gravitational field all around the earth. As we said, how can we define gravitational force? Is the interaction between the mass and the gravitational field created by other mass. So I gave you an example. If I want to define the gravitational force exerted on a satellite, okay, a satellite is not touching the earth, so why this gravitational force here is present? Because the satellite, the mass of the satellite, is interacting with the gravitational field of the earth. So the gravitational field of the earth, girls, is not like just close to the earth. It extends to large distances, to very far distances, okay. Because you know, girls, even the gravitational force of the earth, it's exerted on the moon, right? So this region around the earth, it extends to very far distances till the moon and farther distances. Okay, how can we, so this gravitational field is something that we can't see. Okay, so how can we represent it? We can represent it by vectors. These are the vectors, the blue vectors. Okay, so we represent it by vectors. These vectors represent the Earth's gravitational field at each point. Note that the field has the same strength at equal distances from Earth's center. What does this mean? What does this sentence mean? Pay attention with me. Let's say here we are at this orbit, okay? And this orbit, and here, girls, the distance is at this orbit, the distance is at this point is equal also at this point, okay? The distances are equal. So here, if you have an object, because the gravitational force, or here the gravitational strength, sorry, will be the same as the gravitational strength here. So pay attention with me. This field, this region, it has a strength. It is a quantity in physics, okay? It's not only an imaginary region, no. It's a region that it has a strength, it has a value, okay, and direction. So that's why we say gravitational field is a vector quantity. So gravitational field is a vector quantity. What means vector quantity? It has both magnitude plus direction. What is the magnitude of it? It is the strength of it, okay? How strong our gravitational field is. So this strength, it has a value. We will see how to get it. Okay, so this strength has a value and it has a direction, which is always how the direction, it's always toward the earth. So at a specific distance from the earth, the gravitational strength, the strength of the gravitational field is the same. So what do you expect if we go to a farther point? So if I compare this point here, this point A with this point B here, okay, what do you think? Where is the gravitational field stronger? For sure the gravitational field is stronger at the point closer to the earth, okay, than the point farther from the earth, which is farther from the earth, okay. So the closer we are to the earth, the stronger the gravitational field is. But this doesn't mean that when we go far there is no gravitational field. There is, but its strength is less than its strength when we are closer to the earth, okay. So I hope you understand the meaning of gravitational field. So gravitational field, it's a region around any mass. We usually talk about the gravitational field around the earth. So it extends to very far distances. This gravitational field is a vector quantity. It means it has a specific value. We will see what it is. And it has a specific direction. Its direction, it's always how toward the earth. Also, it's useful to know that at a specific distance, at a given distance from earth, the gravitational strength is constant, okay. So the farther we go, the gravitational strength becomes lower. Okay, so at any point, Earth gravitational field can be described by gravitational field strength and is equal to what? Okay, type. So what is the gravitational field strength? So first of all, you will see that the gravitational field strength we will represent it by the letter G. Okay, gravitational field, we said it is a vector quantity. It has magnitude and direction. The direction, it's toward the Earth. The magnitude, what is it? The magnitude, it is the strength of it. So gravitational field strength, it has this symbol G. Okay, what it is? So let's, for example, say that my object or my satellite is here at point A. Okay, I want to find the gravitational field strength here at this point exactly. So the gravitational field strength here, it's equal to the total force exerted on the satellite by the Earth divided by the mass of the satellite. Okay, so the gravitational field strength is equal to the total force, the gravitational force exerted by the Earth on the satellite divided by the mass of satellite. Okay, so why we divided by unit mass? So see, it's equal to gravitational force exerted on a unit mass. Why we divide by mass? Why? It's force per unit mass. It's force per unit mass in order to get a constant G at a specific distance. For example, if I'm talking about this sphere, okay, this distance, so by using this equation for this at this distance from Earth, we will have the same value for G here or here or here. Okay, whatever the object is, we will have the same value of G. That's why always the gravitational field strength is defined as gravitational force, total gravitational force per unit mass. So Newton per kilogram. So it's measured in Newton per kilogram. Okay.